Hello and welcome. In this video, we will be discussing physiologies and physiology schedules in GPX. If you recall from previous videos, these are the components that go into a simulation, each represented by an asset in GPX. First, of course, we have the compound, then how it is formulated, and how and when that formulation is dosed, and of course, topic of today's video, who it is dosed to, the subject and the physiology of that subject. It is important to remember that we have the pharmacokinetics as well that exist at the intersection of the compound and physiology. So what is a physiology in GPX? A physiology is an asset, and it is a snapshot of the subject's physiology at a single point in time. And what do I mean by that? Some characteristics, like the species of the subject, are immutable. They will never change. Others, like age and weight, may change, but over longer timescales, and that may or may not be relevant to our simulation. But some parameters, like changes in gut physiology with meals, are very important for the types of PBPK simulations that we do, and these are likely to change daily. And so it's important to be able to simulate these in GPX. And so how do we capture these changes over time? We use a physiology schedule, which links a series of physiologies, each one representing a state, i.e. the fed state or the fasted state, over time. So physiologies in GPX are used within physiology schedules. And physiology schedules are also a reusable asset, and they are the ones that are actually called by the simulation. So physiology schedules are used as the building block of the simulation, and then as the simulation runs, it uses the physiologies within that schedule at the appropriate time. And we can see an example schedule over on the right, where we have a fasted and fed switch with meal times, and that we see changes over time, and this is what would be used by the simulation. And each physiology schedule must have at least one physiology event at time 0 for it to function properly in the simulation. An important note is pharmacokinetic parameters exist at the intersection of a compound and physiology pair. And what this means is when we create additional physiologies, before we can use them in a simulation, they must be paired with the compound so we have pharmacokinetic properties for that compound and each physiology. And we will see in the example today what is called the physiomolecular pop-up window that makes for easy pairing as we create new physiologies. So in the example today, we will start with a project that already has a compound, a formulation, and a dosing schedule set up. You can see an example of the dosing schedule that we will use, which is just drug administration with meal times down at the bottom. And then we will create the default human physiology, edit the pharmacokinetic parameters so that we can observe the pairing that we talked about. We will look at the schedule that is created automatically when we add that physiology and run a simulation with it as our baseline. Then we will go back, create another physiology, this time in the fed state, and then we will pair that new physiology with the compound so that we will be able to use it. Finally, we will create a more complex physiology schedule representing meals, breakfast, lunch, and dinner at 7 a.m., 12 noon, and 5 p.m. respectively, with the fed state lasting for 2 hours. And you can see that example schedule over on the right. Then we will set up the simulation using the new physiology schedule and observe and compare the results. So if we switch over here to GPX, I've already loaded the project. And again, we have a compound already created, just the generic compound X. Under dosing, we have our IR tablet asset, and we've used that asset in the dosing schedule for 100 milligrams of that IR tablet with meals at 7, 12, and 1700 hours, representing breakfast, lunch, and dinner. Now, if we go to the physiologies view, we can add our first physiology. I'm just going to call this default human fasted, but again, you can call it whatever you want, but make sure it's descriptive enough that you and anyone else using your project will be able to tell what it is. So we have our default human here, and if we go down to the gastrointestinal panel, that's where we will find our meal settings and our fed state. And by default, is the fasted state, so we're going to leave this alone. Now, if I go to the pharmacokinetics view, we have the default options set up. This was our first physiology. I'm going to go ahead and edit the blood to plasma concentration ratio. I'll make that 0.55, and I'll change our fraction of bound in plasma, our FUP, to 50%. And again, the reason I'm making these changes in this example is that so we can observe the physiomolecular pop-up when we create the next physiology, so we can demonstrate that. Now I'll move to the physiology schedules view, and we'll see that it's already automatically created a physiology schedule for us. And every time you add a physiology, whether you're adding a new one or copying an existing one, GastroPlus will create a default schedule using just that physiology at time 0 for you so that it's ready to use in simulation. So it just automates this step for you. Now, if I move on to simulations and I click add, we can go ahead and call this human fasted 3 doses, because again, the dosing schedule still has those 3 doses at meal times. So even though we are not yet simulating meals, we're still going to use that schedule that has the 3 doses. And then we'll be able to compare that once we do administer the meals, and so we can see the effect of the fed state. So we'll click OK. That will create our simulation. And if we open up the drug administration panel, we'll see it's using compound X and our dosing schedule, selected those by default, as those are the only compound and dosing schedule assets we've added. And we also only have 1 physiology schedule asset, which you can see down here. And it's the only one in the dropdown, so it has conveniently selected it, but that's simply because it's the only one we've added so far. So now, if I click Run Simulation, we'll go ahead and run it. Now we can see our 3 drug administrations at the indicated times, 7, 12, and 17 hours. So now, if I go back to the physiologies view, we can go ahead and add our fed physiology. So I'm going to call this default human fed. Click OK. And this is the physiomolecular pop-up window that I was talking about. So we see the molecule is compound X. We were already on compound X. And this is the name of the physiology I've just created. And what it is asking me to do is to select a set of physiomolecular, physiology, molecule, or pharmacokinetic properties for an existing compound physiology pair. We only have 1 other physiology, so that's the only option here. But if you have multiple physiologies, you will have multiple options here to select from. You can just click select to select those, or use default, we'll just use the default options. In this case, we're going to click select to use the FUP and RBP that I previously defined for compound X in the fasted human physiology. And again, we wouldn't expect FUP and RBP to change from fed to fasted, but there are scenarios where you might have different physiology, such as a healthy person versus a person with cirrhosis or some other disease state where those values might change. And that's where you have this window to select which one you want to use when you add an additional physiology. So we'll go ahead and click select. We'll stay on this physiologies view for just a moment so that we can edit the fed state from our fasted default to fed. And once we've made that change, we'll stop by pharmacokinetics once again and observe that the changes that I previously made are now present for our fed physiology as well. And that was what we did with that pop-up window. And now we can move on to physiology schedules and create our fed fasted switch. And I would observe that we have our default fed human schedule as well. So we added that in physiology and it created one by default. So now I'll add a new one that we'll give our meal times at, and I'll call this 3 meals at 7, noon, and 5 p.m. Say 7 a.m. just for clarity. You can name this whatever you want, but again, just be descriptive enough so that you know what it's doing. So we'll click OK. It just happens to start with a fed, so we need to make sure to change it to fasted, because again, we're starting in the fasted state. We haven't yet done our first meal, which is going to be at 7 a.m. So 7 hours. It will be random to an extent what is in this dropdown, so make sure you select the correct one initially. So then to add our next one, to add a breakfast, click add. You can set the time to 7 or 7 a.m. and change this to fed. And we said that the fed state will last for 2 hours. So then at 9, we will change it back to fasted. Now I can create the rest by using add, or there's this copy button. So I can highlight a row by control clicking, hit copy, and it will add the fed below. Now, when I only have 2 physiologies, this isn't very important, but if you have 20 physiologies in your project and you don't want to find them in the dropdown every time, this copy button can expedite the process a little. And then we'll go on and we will do dinner at 5 p.m. and say that the fed state ends 2 hours later at 7 p.m. So with that, we've created our physiology schedule. So now all we have to do is create a new simulation in which we will use it. I'll call this human 3 meals. Click OK. And again, we only have 1 compound and 1 dosing schedule, so those are already in there. And it has put this here, just so happens that this was the first one in the list in alphabetical order, so that one was selected. But depending on the name, you may have to expand this physiology schedules dropdown and pick the correct one that you want to use for the simulation. So I can go ahead and click run. Let it run. And now we see, if you remember what we had before, this looks a little different. From memory, if you don't remember, very simple, just go back over here to the left, select the old one, and we see the difference between 3 doses, but always fasted, versus 3 doses with meals. And we can see what we expect, where certainly the longer stomach transit time with the meals leading to slower absorption, and maybe some other differences in gut physiology creating these changes as well. So that is how you use a physiology schedule in GPX.